Okay, we ready to get started? This is it, right? Quizzes. Susan get finished today? Tomorrow? I can't remember. Susan. Is there a quiz soon? Okay. Well, here it is. So we're finishing chapter 3, and we're going to have a quiz in 2 days over chapter 2 and 3. And I only don't even have half of it written, so I'm a little behind on the time. Where do we want to start today? I have a few more things to pass back. Those who just came in a little late, and I'll pass it back during today's in classes, which we have at the end of class today. And then you're not going to have any homework, but you know, I'm going to post some problems from chapter 3 with the answers, so if you want to print them to have them or study them or whatever you want to do. So that should help you. All right, chapter 3. Chapter 3, are you ready? This company makes bike frames. They make 2 different ones, deluxe and professional. The anticipated profit from the deluxe is $10 per frame. So what I want you to start thinking about is what decisions are going to have to be made from this story. How are these numbers going to be used? We're creating the linear programming problem as we read it. Deluxe and professional, the 2 different ones. They both are using special aluminum and steel alloys. The anticipated profit is $10 for the deluxe, $15 for the professional. The number of pounds, now I don't want to emphasize pounds, I'm going to just call it units because a whole bunch of these are using different units, so I'm just saying whatever the units may be, I'm going to stay in general. However many units of each alloy, steel and aluminum, are on the next slide. But obviously the point is, deluxe probably uses both some steel and aluminum. And the professional frame probably uses some steel and aluminum, but there's probably only so much steel and aluminum that's sitting in our docks, in our warehouse that we had dropped off to prepare for this production cycle that we're about to start, that you planned out last week. And now we're going to get started this week. But last week, when you were planning it out, you realized only 100 pounds of aluminum got dropped off, 80 pounds of steel, and that's it. 80 units and 100 units to stay a little more generic. Now, when we're making these, and we happen to make the deluxe, it's going to use 2 units of aluminum, 3 units of steel for every deluxe frame we decide we're going to make. And for every professional frame, 4 units of aluminum, 2 units of steel. For every one we're going to make. What needs to be decided? Maximum amount you can make, yes, but more to that.
With the constraints?
With the limitations we have. What's the limitation? What's name and limitation? Be more specific. Name a limitation.
Supply.
Well, be more specific.
The amount
Of?
the products.
Which product's that?
Aluminum and steel.
And steel. There's the limitation. Less than equal aluminum, less than equal, or greater than equal? Less than equal, because there's only so much we can use. We can't go over what's been dropped off, right? It's either 100 or 200, I'm sorry, 100 or 80, and that's the most we can use. Each of those are less than equal. You can write the right-hand side of these constraints right now. Less than equal 100, less than equal to 80, right? I'll do it. Can't see any of you moving. Count me in. Now, we have to figure out what decisions to be made so we can convert then those decisions to represent what this limitation is and represent this limitation. This limitation is aluminum. This limitation is steel. Whatever it is we're trying to decide is probably using some aluminum and some steel. Is someone ready to tell me at least what one of the decisions are? Give it.
Sure. So for like the 100 pounds of steel, would it be like 2?
Well, no, hang on. She's almost, you're jumping ahead of me, but tell me what one of the decisions that have to be made that we're doing all this for.
We got to figure out how much aluminum and...
Almost. We do need to know how much aluminum, but you know what's going to happen? We're going to try to use almost all that aluminum and almost all that steel. But how? There it is.
Yeah.
Okay, tell me, say it again.
Between the deluxe and professional.
True. If we wrote the variable right now, give me, I don't know, let's call it, what's the first one, deluxe? We wrote the variable D for deluxe. What words would be right there that D represents? What is that decision? How many? That's the key words too. not how much or whatever, how many deluxe frames. That's the decision, because we're planning production. This is last week. Production's starting this week. We're pretending like this is last week, and they have to know today, before everybody gets here in the morning. It's already 5:30. We're already here. We're management. We have to be here at 5:30. How crazy is that? If that doesn't make you quit, nothing will. Wait, do you guys ever sleep in? When I was your age, that's all I did was sleep in. No? All right, that's it. D equals number of deluxe. What's the other decision? Number of professional. We'll call it P, professional. Those are the two decisions. Now, Charlie, now I want you to connect those decisions to what you were telling me about the limitation on, help me out, aluminum.
Yeah.
You got to connect these somehow. This represents not how much aluminum is using. It represents how many we're going to tell production to make. So turn it into something.
2D.
Yes, 2 units of aluminum for every D we decide to set production up to do,
Plus 4.
plus
D.
4 units of aluminum for every professional frame we're going to decide to have production made. There's the total aluminum we'll end up using based on whatever we decide production is going to be next week. And we can't go over 100. This should make the other one easier, just as easy. Give me the D. 3D plus
2D.
2P less than or equal to 80. All right? So far, from what we've read, do you see, is there a constraint in here or not? Did we skip a constraint? Go ahead, Chase.
Is it a max problem where you're trying to maximize the profit?
So no, we didn't skip a constraint. It's his way of saying we skipped the objective function. And since he determined that since the words on this story problem is about profit, right? The amount of profit we expect on the deluxe is $10, $15 on the professional, that this must be a max problem. And sure enough, that's exactly what it is. Chase, you took it this far. Someone help finish this. Give me the exact objective function I'm going to write here using the variables.
10D plus 15.
That's right. 10D plus 15, you said P, correct?
Yeah.
But equals? Less than equals? Greater than equals? Never.
Yeah, never.
Oh, God. Someone's still at that point. That's crazy. Never equal. Don't even put an equal here by accident. I'll go with dots or something if you must put something. But just leave nothing. All right? There's the whole linear programming problem for what we just read right here. Now, on Blackboard, if you go to course information, you'll see, no, where's it at? Hang on. Something new there at the bottom. All right, a zip file. Download the zip file, save it somewhere. Don't open it. Save it. Locate where you saved it at, probably in your download folder or your management science folder, wherever you're going to download it. Then, is it right click? Right click on that folder you just downloaded, select extract. Extract it, then you're going to see, hang on a minute.
Oh, is that the link for the?
That's going to give you the software. It's going to look, you don't have to pen drive, you can if
I
you
don't
want.
have to give you the flash.
You don't have, you have it right here if you want it. It looks like this after it extracts. This is the one to start it. But if you just double click on it like normal to start a software, most of you are going to get an error message. So here's the roundup. To get around it, go to that executable file right there, right click, left click as run as administrator the first time you run this. Runs perfect. You can close it, open it, normal from that point on. Once you run it once as administrator on your whatever computer you put this on, okay? So there you go.
Does it work on Macs too, or just
No,
PC?
it won't work on Macs, but if you reach deep on the internet, you may be able to find a fix for that. But what I think the hardest fix is, I don't know if there's something easier, is that some people put 2 operating systems on their Macs where they can go between, what is that, IO or OI or whatever? IO. Goes between IO and Windows on a Mac. Anybody ever seen that where they can go back and forth? The Windows side, you can get that 2 operating systems. That will allow this software to work every time. But the other side, when you go switch back to the other operating system, it won't work. I heard there is a way to make it work on IO or OI or whatever, but I don't remember. I heard it's very difficult, and you'd have to go into, I don't know, join your program. If you want to, please let us know if you figure out a way around using Mac IO software. And real quick, I almost forgot. Go to any U of M webpage. Hang on a minute. Josh, you ready? This is if you don't download the zip files. You want to do it this way. Then hit the search, put labs anywhere. I'm sure all of you have done this before, yes? Lab anywhere. How about you've never done lab anywhere? Raise your hand. Oh, never heard of lab anywhere? Raise your hand. Well, while you're at home, since most of you have never experienced this, you can be on a lab computer from home anytime you want, as long as you got the internet. You don't have to come to the school to use the lab computer.
So, are you allowing us to use the internet then?
Not during the quiz.
Okay, so just, okay.
Well, you know, to use the software, you know, a lot of people are asking for the software and to use it. This is an easy way from any computer. You go to Lab Anywhere, hang on, let me click on it. Just click on that, go down here, right there where it says, you may access this service by visiting this web page. Left click on it. So again, I went to any U of M web page, I hit search, I did Lab Anywhere, follow the links to get to this point. Did I do it already? Now, I've never done this, and I've heard this is kind of tricky, but this works every time. Just use HTML. So HTML, you click here, it'll ask you to sign on, your username and password, just like you're doing your email. Hang on. I'm not going to sign on. Username there, hit login. Find something to keep you busy, because most home internets are only maybe 10, 20 megs at the most. This is a big deal. This hooks up a straight line live to like a lab computer. You're mirroring it. And all of a sudden your start button, where is my start button? It's not even on here, is it? Right here, my start button, another start button will appear above it because you're on a lab computer. You're seeing the lab computer screen within your screen. Now, you can minimize it if you want, and then you open up the lab computer, and every program that's on a lab computer, if you want to use it, is to your access from home. As long as you have as long as you can still use email, you can use this, just like you're sitting in a lab. So, write that down.
That's awesome. I actually just did it while you were talking about it.
So, there's that. But man, the scientist isn't in the lab, is what I just found out. I forgot to end that part. But you can get the zip file. God, I forgot about that. I tried it and couldn't find it on the lab computer. Hang on, where did I go here? Where is it? Right here. And then when you open up, you extract it wherever you're going to place it. Put a file called Management Scientist on your computer. You download it, you extract it, it looks like this. Right click on that executable file. I think that's MS60 maybe or 6.0. Right click on it, run as administrator, left click, first time, and then you just got to double click right there and it runs. You can even transfer this now to a pen drive and get it off your hard drive, and it runs from the pen drive. You just put it in, go to it, and double click on this, and it runs from there as long as you run as administrator once.
Well, if we put it on the pen drive, will it run on Mac at that point?
No, because it has to have an operating system it can communicate to.
You probably save it to the lab anyway.
You know, I wonder, if you don't want it on your home computer, like you said,
I think with the Mac you get around by
you
using the lab.
can get on Blackboard while you're on the Lab Anywhere computer, and then download it to that computer and extract it and open it up. Now, will it stay on that hard drive at that lab computer? What's the odds you get that same lab computer hard drive? I don't know if there's any connection to your email address to that lab computer connection or not.
You might be able to save it onto your H drive. I don't know. And then
Or you guys have an H drive?
everyone
has like a.
everyone has a personal drive on the
Yes,
school
put it on
system.
there then. Yeah,
and then
sure.
if it gets uninstalled, you could just reinstall it and save the
Things
zip
get
file.
uninstalled. Oh, you mean
off the lab computer's drive, but
yeah.
yeah.
All right, you ready? So this is where we were, right here. We have our objective function. We have our two constraints, right? Are you ready? I just posted this output this morning. So this is there for you to connect the notes you're about to take to that output, a picture of this output, because it's been there this whole time. You had to use the software to get this output, but now I did a screenshot and put it on there as a picture to make it easy. And that picture is right, I don't know where it is. Right here. This is it, right? $10, $15 profit on the other frame, right? And we only have 100 units of aluminum, 80 units of steel, correct? Everything matches up. Are you ready? Again, you're not ready? Okay, hang on, let me get this here, let me get this here, there we go. Here we go. Suppose the profit on the deluxe frames is increased to $20. You gotta think about deluxe frame, which variable represents deluxe, what is it currently? It's gonna go up to 20. Is the above solution, optimal solution, still optimal? Or will it change? Let's stop right there. Anybody got a yes or no right now? And ready to explain where they got their answer? Yes, yes, yes.
Upper limit,
It's within the limit.
Tell me what the limit is.
42.5.
That's right. Where are you looking, and what part of this output are you looking?
The objective
Coefficient.
The objective, what you just said. Objective coefficient ranges. Found variable x1, which is what's being used here, $10 profit. It says the deluxe frame is going to go to $20, right? It can go all the way. Now this could be allowable increase, so you got to be careful. But this says upper limit. If it said allowable increase, what would be the number right there? Oh, not all at once. We are
12.5.
12.5. Thank you, Hunter. The difference between the upper limit and the current value is the allowable increase. The difference there, 12.5. This is increasing how much, Tom? Right now, the profit on the deluxe frame is going from 10 to what? Someone help him.
5.
No, 10 to what? 20, which is an increase of how much, Tom?
5.
No, but I appreciate it. It's an increase of how much, help Tom? 10,
Oh, that's.
but it could increase how much?
12.5.
12.5, we're within the limit, right? Which means, what is the optimal solution for deluxe frames? If we were talking to production right now, how many deluxe frames would we tell them, and where's it at? 15. Now, Hunter is not answering all these. Help them out. 15, where's it at? What represents how many we're making? We're just scheduled for production. Where's it at?
Value.
The value up top. This is always the optimal solution, and the decision is how many deluxe frames, how many, what are the other ones called? Professional frames. So right now at production, they're about to start. You got in work early. You have it all planned for 15 and 17.5 this week to make sure we don't go beyond our 180 units. But then, would the value of the objective function, what is the objective function value right now, by the way? 412.50 cents, which really represents what? 412.50 cents in words. What does it represent? The objective function value represents what?
Profit.
Not just profit.
Maximum.
The maximum profit we could get with this situation of only having 100 units of aluminum or 80 units of steel. There may be a different amount of deluxe and professional frames to make, which is called an alternative optimal solution. There may be a different amount, but no other answer will get us more than $412.50. We could get a tie, but there's no better amount of profit we could get based on these limitations. All right, everybody get it? What would be the new, and how would we find the new objective function value? Let's start with, how is that 412.50 being calculated using this area? Give me the first number. What number? 10 profit for every deluxe frame we just scheduled, which is how many? 15 plus $15 profit times every professional frame we just scheduled. You add that together, that's 412.50. Now be careful. As Tom told us, the profit is going from 10 to 20. So we have to recalculate. What is 20 multiplied by?
3.125.
15. 15. So 20 times 15 plus 15 times 1750. We changed that one number. For those who love math, we'll do the shortcut. This went up 10. 10 times 15 is 150. It increased, so we're increasing that by 150. And you get the same answer. There's your new objective function value. Which, if for sure, on your quiz, if there's a question about something changing, it's going to also say, show your work and calculate the new objective function value. Because every change affects the objective function value. If the changes are in this area, this tells you how it's affecting it. If the changes are in this area, this is telling you how it's affecting it. Right? Make those connections, draw some lines, whatever you got to do. All right, next question. The output states that the solution remains optimal as long, oh, we just did this, Well, the objective function is still between 7.5 and 22.5. Because 20 is within that range, within that upper limit, the optimal solution will not change. I want to give you a heads up. This may be the benefit of showing up today. On the quiz, which you know is going to have a change, you need to state if that change is within the limit, no matter what. The limits is the first step, no matter what change, whether there's one change, two changes, three changes. Step one is you got to describe if it's in its limits. You must. There's points there every time there's a change. The new objective function value would be 20 now times 15 instead of 10. 15 times 17.5. It goes up 150. That's right. 562.50. Okay. Next. If the unit profit on the deluxe frame were $6 instead of 10, it dropped. Would this optimal solution of 15 and 17.5 still be valid? Yes or no?
No.
No, because it's what?
Lower limit.
It went outside that lower limit. The 10 could drop all the way to 750, and those are still okay. But this is going to 6, and because it dropped a little lower than that. Now be careful. I'm trying to get you prepared for what could be in your future, whether it's homework or in class or test or final. This may say $10 is the current value, and the allowable decrease is $2.50. This says it's going down to 6. How many units is it going down? 4, and it could only go down 250. That's another way to see it's outside the limit. You're using the amount instead of the limit itself for what it equals, okay?
So just wanted to clarify, basically on the quiz, you will give us like a chart that looks just
You'll get an output. It may not look exactly like that. It may look like the ones in the book.
Okay, yeah.
But it's going to be one you've seen before, either from the book or from here, as far as the setup. But it, you know, you got to be. I need to prepare you to be able to read any output, because it's the same information on every output. Once you get familiar with how to read these, it's just giving it to you in different ways. Excel, in operations management, you're going to do this again using Excel, the analysis pack, I think it is, and it's going to give you all the same information very different than you've ever seen it. But you, if you understand this and understand that all this information exists on every one of these, just in different ways, you'll be able to figure it out. You'll see the logic. All right? Here we go. The output because it's below the lower limit. Okay. You ready? Hang on. Hang on. Simultaneously, the profit on the deluxe frame is going from $10 to 16, going up. While the professional frame is also going up from 15 to 17. You with me? Step one. What do you do?
figure out if it's within the limits.
Within the limits. Are each of them within the limits?
Yes.
You're going to state each change. You can be as simple as that. You can do them individually or however you do it, but somewhere on that answer, you got to tell me if they're within their limits. Each of the two changes are both within their upper limits, signifying that you know they're going up. Next, step two. What do we do next?
Don't you identify how much is changing and then multiply it by the...
No, almost. Identify how much is changing, then what? Help her. No, almost. Identify the amount of change and then do what?
Divided by how much it could-
Divided by how much it could have changed in the same direction. You were going past where you're adding the changes.
Yeah.
You got to take the amount of change that's happening and divide it by the amount of change that could have happened at most, and not change that optimal solution in the same direction. There's the key words. I'll have people, where's the first one? 10 to 16, right here. They'll look at the full change, but you only, it's the amount of change in the same direction. If this 10 were going down, you'd say the most it could change then is 2.5. But it's going up, so the most it could change is
12.5.
12.5. How much is it changing?
6.
6. Give me a calculator, 40.4 something.
48.
48? 0.48. Now, look at the other one. The professional is going from 15 to 17. How much does that change? 2. How much could it change in the same direction? 5. I'm going to check this. It's going up, and it could go all the way to 20, which would be 5. I want to make this easy, though. If that were allowable increase, it's giving you the number that will be the denominator in that output. Makes it even easier. this is 5. 2 divided by 5 is 0.4, I think, or point, yeah,
Yep.
0.4. Add these together, I get 0.88. You must show me you're comparing this to 100% somehow. Write something here. I always say is less than 100%. You'll see me circle that on a quiz saying, the comparison's taking place. They know to compare to 100%. And then you're going to write, you're going to tell me the answer to the original question, which is, you're going to write what? The optimal solution is still valid or will not change, or whatever word you want to use that says you've looked at, they're in the limits, you looked at that it's less than 100% of the amount of change, and those have told you now that the optimal solution of 15, 17 and a half are still valid. We don't need to recalculate this whole thing to find a new optimal solution. That's still valid. But, of course, you're going to have to calculate the new objective function value. Georgia, are you ready? I'm sorry, you're not ready? Jonathan, you ready?
Yeah.
Okay, let's do it. New objective function value. I'm going to start with what number? Give me any number. Any number.
16.
16. 16 times
10.
15. Are you giving up on me? I can't hear. You guys are helping them. Is that what's happening? Okay, I'll give up. Go ahead. Give me the rest.
Plus
Plus what? 15 because it went from now
17.
17, but 17 times.
17.5.
So it's the new profit amounts. This went from 10 to 16 times the optimal solution that we just discovered still valid. That's why we can use these numbers. And then this new amount, 17 times 17.5, added together is our new objective function value. What is this?
537.5.
537.5. All right. Now I want to show you the shortcut. 6 times 15. That's let's see, 30, right? And 30 is that 90?
Yep.
So we're adding 90 to it, and then this went up 2 times 17 and a half would be 35. So we're adding 90 and 35 to that, which will give us 537.5. That's the shortcut. Either way, you can get to the new objective function value. Both of these changes, we did a single change, we did a simultaneous change. Both changes had to do with the optimality or the feasibility of this output. Optimality. Anything related to the objective function numbers is the optimality, range of optimality. Anything that has to do with the right-hand side of the constraints is the feasibility, range of feasibility. All right, next, ready? Blah, 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 blah. We measured all this. We got this. 40%, they add up to 88. Is that what we got? 88. 88 does not exceed the 100%. Therefore, the optimal solution would not change. Right? Right? And now we're talking about feasibility. We already talked about it. Here it is. Given that, oh, no, we're at this point. Are you ready? Here it is. This is the part I told you was coming today. Sunk cost, relevant cost. All right. I should put in my own words first and then let you see the slides. I can't remember slide number 13. But I don't want this to confuse you. Relevant cost is the amount paid, is dependent upon the amount of resources used in the decision variable. Relevant costs are reflected in the objective function. Okay, forget that. Who cares? All right? For this class, don't get me wrong, if you guys are getting to a point where you're using linear programming, and I hope you do, that'd be great, you need to know the difference between relevant costs and fixed sunk costs. But for this class, here's the key. I'm going to tell you if the cost is relevant or sunk. And you need to realize, if I say sunk cost, sunk, which means it's not built into the objective function, who cares? This is telling you the most you're willing to pay for one more unit of that resource. Dual prices. Everybody hear that? This is the max. And let me add to this story. This is the max. You want to pay less than this because this is telling you just to break even on an additional. Hey, we have a little bit more of aluminum. Was it aluminum 100 or steel? Aluminum. We have a little bit more aluminum. We're in your area. You know it's a sunk cost. and we're offering it to you for $2 a pound. We need to know now, though. Yes or no? I heard a no, and I heard a yes. Anybody want to jump in? Any more yeses or nos? I hear a no, I have 2 no's, 3 no's. Well, go ahead.
No, because it's higher than that.
Which one represents steel at the dual price? Which one?
Oh, the top one represents.
$3.12.5.
So it'd be yes.
And they're offering to us for 2, and it won't be yes. It will be, I'll give you $1.75. That's your reply. Do you understand? Or you're fired. If you're not negotiating, you're not earning your pay. You've got to negotiate it. But $2, you know you're going to take it, even if they don't negotiate. But spend at least a couple minutes trying, okay? Yes, that's the decision. That's telling you the sunk cost. That's what you're looking at. And now if it's relevant cost, go ahead.
Didn't you say that the most you're willing to pay for one extra unit is the dual price?
Dual price, which is $3.12.5 for the deluxe grade.
So what's the sunk cost again?
Sunk cost, you're being told that aluminum is a sunk cost. That all you got to look at is the dual price to determine yes or no if you want some additional units based on the supplier offering you at a certain price. This is real life. You get calls from the supplier. Hey, you know, we're about to deliver your order, and the worst call you get is short. That's a very common call, by the way. But we have extra. Could you use 10 more pounds? Could you use, 20 more pounds? And you got to make a decision quick because they're going to offer it to the next person while they're waiting for you to call back. You just have this already done, and you know it's a sunk cost, and they said $2 a pound. You negotiate it. You try to get less than the $2 they're offering it, but you're going to take it even at $2. This is telling you you're going to make $3, and this will increase that maximum profit based on the frames you're making by that much for every additional pound you can get your hands on. Up to, how many pounds are they offering us? 10? As long as the increase is within the upper limit, then that is still valid, and we can make that decision right then. Right? I want to do another sunk cost. I want to make sure you guys get this before we go to relevant, because relevant's hard. You ready? Hey, steel supplier just called. You know it's a sunk cost, and they're offering us additional 20 pounds, 20 units. My question for you is, yes, they're offering it for $1.10. Yes or no? Do you take it, yes or no? Yeah. Let me look. Okay, good. What did you look at first? What did you look at first, though?
Dual price?
No, what did you look at first? The upper limit. You wanted to make sure that 20 pounds were within this limit so that is, so you can have faith in what that says right there. So you can make that decision that quick. You got to make sure. This is telling you that's still valid. And now you're going to say yes, but isn't she going to negotiate that even? $1.10, if you could just save 10 cents. I know it's only 20 pounds, but in real life that's probably 20,000 pounds. So 10 cents would mean a lot. If you like that, if you like reading these and you think this is interesting, start searching Indeed. Is that where you might go? And look for manufacturing buyers positions. There are a ton of them. If this is something you like. Everything I'm teaching you, every chapter is a job out there in the real world for big companies. You put this all together to be a one-man operation for a medium, small company, you're a hero. Because they're probably not using this stuff. They need somebody like you to come in. Okay? Big companies are using this every day.
Does it matter if it's a minimization versus a max with this stuff?
No, it doesn't matter max or min when it comes to the cost. What will happen though is a minimization, you might have a negative here, and you would never want additional units.
So even though it's over the minimization one, you still want it to be less than whatever the dual price is?
Well, if it's a sunk cost, and if it's within its upper limit. Let's do relevant cost now. You ready? You ready? Relevant cost is similar to sunk cost, that this is the most you would want to spend over and above the normal price you already paid per unit for the original amount. Where's the 180? I erased them, but remember these? 180 is the amount we dropped off. You need to know how much you paid originally for those units. Maybe we paid $5 per unit for aluminum, and we got 100 units dropped off, right? They just gave us a call, and it's a relevant cost. And you know you paid $5, and they're offering you another 10 pounds, 20 pounds. They're offering you another 20 pounds for $7 per unit. Do you take it, yes or no?
Is it for,
No.
I'm sorry?
is it for aluminum?
Aluminum, and it's relevant. Again, the key you're thinking about here is the dual price, because it's relevant, is the amount of premium, the most premium you would pay above regular price. And they're trying to get a premium from you because they only charge you $5 a unit, and if you want these additional units, they're saying 7, right? 7? 7. Do you take it, yes or no?
No.
Yes, after you negotiate.
Thank you, Hunter. There was a no, though. And he says yes. What was the first thing you looked at? Upper limit. I said, how many units? 20? Dang, I was trying to actually go over that without looking. But, okay, 20 units, so it's within the upper limit. The dual price is still valid, but you know it's a relevant cost. You know it's $5 per unit, usually. They're offering it for 7. This is the most you would pay above regular price, which would take it to what price? 8, 12 and a half cents, 8, 12, whatever, right? You get it? As long as they're offering it to you for less than 8.12 and the amount of units within the upper limit, you're going to say yes after you negotiate.
So, is the meaning of the dual price changes based whether you have irrelevant cost or a sunk cost?
Say that again. I can't. The what? The meaning of the dual price? Yes. Now I get it.
Yes, changes whether you have irrelevant or a sunk cost?
That's right. If it's a sunk cost, the meaning of the dual price is the most you would pay per unit as a buyer. And if it's a relevant cost, the dual price represents the most you'd be willing to pay above regular price, called a premium. So, I want to tell you, if there's a question with sunk or relevant cost, no matter which one it is, you're going to be given the regular price. But if it's a sunk cost, that's information you're not going to be using. I just want to, it's going to be there no matter whether it's a relevant or sunk cost question, because it has to be there if it is relevant.
So, what is the strategic advantage here of you paying more per unit than normal?
Well, if the price per unit's already, hang on, ready? The relevant costs are reflected already in the objective function. And so this isn't really telling us, we already know the regular cost, and we took that into consideration to come up with this $10 profit. In real life, this is probably a relevant cost. And that really, this is telling us, if you want additional units, you can increase your profit by this much, and as long as you, at regular price, you're getting this much additional profit on top of normal profit, on top of that even. But you would only use the dual price. It's just telling you the premium you'd be willing to pay if you had to make a quick decision if it was being offered to you. Why would you pay more than regular price? You actually requested, you know, where is it? I keep pointing to the wrong one. 120 units of aluminum. They only said we only have 100, and you said we'll take it. And at the last minute, they said we had another customer have a cancellation. You could have those 20 if you wanted. But you already did all the math. You gotta remember, there's like, you know, there's probably 10 variables, and there's probably 50 constraints. And you already did all of your calculations and made sure everything was entered in the computer, the software correctly, to get to these numbers. And the time it would take you to redo everything based on this new information would be too long, and someone else would take that opportunity instead of you. You could just quickly look and you make that decision right then and there.
So you're still, with all these calculations, converting them because you're inside the money, you're still making a profit.
That's right. That's it.
So the difference, so the amount that we're allowed to go over per unit is $3.12.5, right?
Over the regular price.
Over the regular price.
Yeah, that's right.
So
We're actually
any-
willing to pay more than regular price. What if that were negative?
Well, you wouldn't do that.
Not true. If this is a relevant cost.
So you'd be paying less than the.
They would have to
Yeah.
offer it to us for less, that much less, or we're saying no. I want to make sure you guys see that. I'm not going to trick you to use a negative because that's getting too deep, but you ready? I want to say that again. This won't work as sunk cost. You would never do it because that doesn't represent the premium. Relevant cost, because that's a premium, there's a chance this could be a negative here. It's not saying you won't take it. It's saying that the price being offered to you has to be that much less than regular price before it's worthwhile to take it. All right, so let's pretend we're going to go now to this bottom one, steel. I want to just hypothetically That's negative 1.25. Everybody with me? Try to man. And then we just got a call, and we're being offered 10 extra units, and the usual price for steel happens to be about $3 per unit. And they're offering it to us for $2.50. No, I'm sorry. What was our regular price? I meant $1.50. They're offering it to us for $1.50. 10 extra units. Can we take it, yes or no?
No.
Yes. No, it's outside of your.
It's outside of the limits.
No, wait, we're 10 more units. 80 can go all the way to 150.
Yeah, but your,
The cost
the
though.
150 lower than that is outside of your negative.
That's 125. As long as they're offering us a price. Okay, well, I see your point. Hang on, ready?
That puts you at
What?
170.
You ready? How much of a discount is that from regular price? This is their point. How much of a discount is that? $1.50 lower.
Right, so 3 minus.
This is telling us how much lower it must be, which would be what price? How much? $1.75. As long as the price is $1.75 or less, we're taking
Oh,
it.
or less.
You get it? This would tell us how much the premium less than regular price would have to be for us to say yes.
Oh, okay.
You got it now?
I thought basically what you were saying earlier was,
You'd have
if
to
they
pay.
offer a price lower than the 175, we can't take it.
We can take it. We want it if this were negative.
Yeah, we thought you were saying the other way though.
No.
Okay.
Okay. So now, let's do it one more time. I want to do it one more time to make sure you get this. I don't want to hype on the negative though. Let's go back to a positive. You ready? The supplier of steel just called and offered 72 more units and this is a sunk cost, and they offered it for $1 a unit. Do you take it, yes or no?
No.
Why?
It's over the limit.
All right, good one. I didn't catch it. Did everybody see that though? I said 75 units. This is at 80. That would take us to 155 units. We can't make that decision on this price here, even though it was a good price. $1 is less than this, and I said sunk, so this tells us rather this is the most we pay, but that is no longer valid because 72 units took us above the max. We'd have to redo the problem to figure out our dual price, whether we take it or not. They're going to offer it to someone else while we're doing all that. We're going to, at this point, I've done these so many times. If you're the buyer, I've done this so much. If you would give it to me for 50 cents, I'll say yes without redoing this. Take a shot at it. Why not? You know you'd make money off that, probably. You start to get the hang of this stuff. All right. Next. Now we're going back to the vice. This is our suck or relevant cost. I can't remember. Is that what it said?
Yeah, it says.
Given that aluminum is a sunk cost, what's the maximum amount the company should pay for 50 extra units? Let me look here. Go ahead. Oh, come on. Don't leave it to 100. This is you're telling me the most they'll pay total. Okay, now I get it. What's the most they'll pay total? What'd you do, Hunter? 50 times what?
3.125.
The most you pay per unit, because this is some cost of 3.125, times 50 gave you $156.25. You show your work would be the most you'd be willing to pay for those 50 pounds. That's the most. You'd never let them know that. That's the most. You know that's your limit, but you try to give them as low as you can. Is there another cost one? Because the cost of aluminum is a sunk cost, the shadow price, which is the dual price, is the value extra aluminum would have. The shadow price for aluminum is the same as the dual price. For a maximization problem, the shadow price of aluminum is $3.12.5 per pound. So the maximum increase could be 60 pounds. They offered it for 50. It was inside the upper limit. So that $3.12.5 was still valid. You multiply 50 is in the range. $3.12.5 still valid. 50 times $3.12.5 is $156.25. It's the most you paid for 50 pounds if it were being offered. If aluminum were a relevant cost, what's the maximum amount the company would pay for 50 extra pounds? And where's our regular price though? Oh, what's the maximum the company would pay for 50 extra pounds? Look, where's the regular price? Well, since aluminum is usually $4 a pound, we get off that answer. Aluminum is usually $4 a pound. What's the most we would pay if it were a relevant cost for 50 pounds? Give me the math. $4, then what? Plus 3.125, which is now a premium. The most we pay above regular price because it's a relevant cost. 3.125. That takes us to 7.125, and then times 50 pounds is being asked about. You get that? You got 300 and what?
56 per
$356.25. Oh, it's asking per pound. We took it past that. We multiplied this times all 50. But $7.12, which is what we have right there, which is the regular price of $4, plus the dual price represents the premium over and above regular price. So that would be the most we pay per unit. They're offering 50, multiplied out, you get $356.25. How do we feel? Most of this was kind of reviewed till we got to the costs. You know this is in your future as far as quiz tomorrow, right?
So relevant cost includes the cost already that we're paying?
Which you will be given, if the question's sunk or relevant, in that question will be the regular price. And you just got to know not to use it for sunk.
Yeah, okay, so some, it doesn't have it.
That's right.
Okay.
It will be in the problems,
Yeah,
but you don't use it.
okay.
Got it. All right, we got it? We're good?
So in the problems, you'll tell us the price. and
I'll give you regular price of what's being paid, and you'll have an output to look at.
And you'll say. if
And I'll
it's
tell you how many
something
units are
relevant.
being offered and what price it's being offered at, and you're going to tell, and show me the math on your decision whether you say yes or no. Good. All right? And if it's sunk, you wouldn't use that regular price that you pay for it. You just leave that out. Man, we spent a lot more time on this one than I planned. I gotta see what the second one was. Oh yeah, that's right. This one. You ready? Hang on. Hang on. Right here. So all I'm doing here, I don't think this will, yes it will. All I'm doing here now is I'm showing you the next problem, which is, I think this is our first minimization problem as far as analyzing the output maybe. Here, we're skipping the story, we're going straight to the constraints, and we're going straight to our objective function. Here's the software. I clicked on linear programming. I said there's two variables, they're x1, x2, and I said there was three constraints. Don't forget, this is less than, even though you only enter less than, it knows it's less than equal. Greater than equal, greater than equal, just like this, less than equal, greater than equal, greater than equal. Right-hand side, see there's only x2 being used here, that's why this is blank, but what else could you put here to mean the same thing? Zero, exactly, put a zero there. You're not going to use the software on this quiz, but you could be given a picture of the software and asked a question about it, or the output. Obviously, you will have a picture of it. Just like Excel, you should plan that there'll be a picture of an Excel spreadsheet with a question about it, right? Something we've already had in this class will be asked about it. I just told the professor that you're going to have an operation, one of them that you're going to have an operation. He asked me about how much Excel we're doing. I said, and I told him one of the first quiz we just had, and I said, every quiz has Excel involved. And he didn't know how we're doing it because he doesn't want his students on the internet while they're taking the quiz. And I said, well, here's how I do it. I do a picture of an Excel, and then they have to write what would be in Excel. And he's going to now implement that with that way of doing it, and you guys get into operations. So, but you have a lot of Excel operations, and I got to make sure you're at least semi-prepared for it. I entered all this. I'm going to solution. Here's the output. Come on. Hang on. There we go. How many X1s are we going to, whatever we're doing with it?
3.
No.
Oh, wait.
No. Where are we? Thank you. Justin, was that you? Jonathan? Who was it? Oh. Hey! I didn't even know you were here. When did you walk in?
I've been here.
Oh, stop. You weren't when class started.
4:07 I came.
7 minutes late. That's what I'm asking you.
I
When
had
did
to
you?
be in the driveway.
I wasn't asking why. Let me make one thing clear. I never want to know why. You know? Thank you, Valerie. I never want to know why. It doesn't mean anything. He's getting marked late. Oh, if that's what, take the consequences. Just eat it.
What about a sign-in sheet? You never started one of those.
Thank you. See, but now you don't know I'm late.
Man, I just can't believe it. We gotta get to the end class with all this time we're wasting. Look at it. I just took a 10 minutes. You ready? the optimal solution for that first thing is 1.5. Whatever we're making, we're buying, whatever we're doing, 1.5. The optimal solution for the second item is how many? And we're trying to keep these costs as low as possible. What's the lowest we can get the cost based on that optimal solution? $27. The optimal, always the objective function's up there at the top. 27 is as low as we can get it. Are you ready? Whatever this constraint represents right here, we just found out that 30 could go to 28. We're not going to get 2 of these, whatever this is. My question for you is the dual price still valid, yes or no?
Yes.
Let's line it up. Where's this at? Top, middle, where's this at on the output?
Bottom.
Bottom, where current value 30, right there. Going down 2 units, right?
Yes.
28. If you go down all the way to 15, that's 15 units, so the 2 is within the limit, which means that dual price is still valid. Look at the dual price carefully.
Negative.
It's a negative. Does that mean you subtract or add?
Subtract.
Maybe.
It's
Well,
making
and-
it to you.
Right? We don't, maybe. It's telling you if that right-hand side is going up, it's going to have a negative effect. Whether that's add or subtract, we'll talk about in a second. Negative effect. This right-hand side's not going up. It's going down. It has to have the opposite effect, positive effect. Now my question for you is, do you add or subtract? What kind of effect? Positive. Do you add or subtract?
Add.
No, stop it.
It's add.
Stop! Stop! Positive effect. Positive effect. If you're a manager, you want your cost to go down. That would be positive. Your bonus relies on this going down. That's what your job is. Keep costs as low as possible. All right? So a positive effect, because this 30 is going down, has to have the opposite of what this is saying. If this were going up, it would be a negative effect, but it has to have a positive effect. 2 units times 60 cents is $1.20, right? Positive effect, because this is a cost, is to subtract that from 27. What was that? How much did I say? $1.20 subtract from 27 takes us to $25.80. So our new optimal solution, our objective function value, would be $25.80, because that positive effect would lower that cost. That's what would happen if this goes down. All right, now you guys are scared, because you had the whole. Again, did we just talk about optimality or feasibility? What are we doing at time? Oh, this one we just did.
Feasibility.
Feasibility, because it's all about the right side of constraint. That's feasibility. All right? And this particular constraint right here is going up 2 units. Up 2 units. That 2 is going to a 4. Is the dual price still valid?
Yes.
Because the 2 could go all the way up to 4, and it happens to be going to 4. That's as far as it can go. The dual price is still valid, negative $4.50. The negative means negative effect times 2 units, right? This is a 2-unit increase. So 2 times 450 is how much money? $9 added or subtracted, negative effect. That's right. This is a cost minimization problem. $9 is being added if this goes up 2 units. And that new objective function value goes from 27 to 36.
Yeah.
And you're going to show how you calculated that. You ready? This 2 is going up to 3, and that 30 is going up to 12. No, hang on. 38. You ready? I got to say that again, because I'm going off the top of my head now. One's going from 30 to 38, is that right?
Yeah.
And the other one's going from 2 to 3, right? Okay, let me clear this. My question for you is, what's the first thing we should talk about?
If it's within the limits.
All right. Charlie, I think you got this. You seem to have this down now.
Yeah.
You do. All right?
Just the.
Does anybody want to be picked on so they can show? James, are you ready? Are you?
Sure.
Okay, you ready? 30 to 38 is an 8-unit increase, right?
Yeah.
But what would be the denominator? Oh, first of all, what was the first thing we checked? If they're in limits. Are they within the limits?
Yes.
Both of them?
Yes.
Okay. 8-unit increase, is that increase or decrease? increase, what would be the denominator?
The difference,
Difference between what and what?
the current value and the limit.
That's right, exactly. And current value is 30, the limit is 55. What am I putting here denominator? 25. Second one, going by 1 divided by 2. I know this is 0.5, 25 is 0.32. We add these up, 0.82. What do we do next? Jake? Ricky? You got it. Ricky, what do we do next? Thank you, Jonathan. Look, he's making up for earlier. He was all over this too. You ready? This is less than 100%, meaning you're showing me you made that comparison. You did all of this just so you can say what?
That it's within the limit.
No. No, not that it's inside the limit. You already said it's within the limits. You calculate numbers that rule so that you could say what?
Within optional.
You don't have to do objective function.
No, stop. You will have it. Stop. I heard it. I just didn't get a chance to say you're correct. But it wasn't that one. What you just did all this for, to see if they're both within the limits, to calculate the numbers that rule, just to figure out if these dual prices are still valid. And that's what you need to write next. You guys got notes? Number 1, are they within their limits? Number 2, 100% rule. Anytime there's more than one change taking place at the same time. Number 3, state whether the dual prices are still valid or not. And you're saying yes, they're still valid, right?
Yes.
Still valid. You ready? Simultaneous change now. Jonathan, what?
So, on the quiz or something, would it ask it, like, are the dual prices still valid?
Yes.
Okay.
Yeah.
So that's how you would know.
It won't tell you which steps you got to get to
Yeah.
to say that. It will say, this change taking place, this change taking place, are the dual prices still valid? And if so, calculate the new objective function value. But you just can't say yes, they're still valid without showing me all of this, including, you got to state on here, they're both within their limits. That, you got to show me you did step 1. Okay? Then, here we go. This is a minimization problem, but the new objective function value is going to change based on each change that just got described. The first change is 30 to 38. We're looking at it. 30 to 38. We already know the dual price is still valid. This right here represents the effect on the objective function value if the change is going up. Is it going up?
Yes.
So this effect will be
Negative.
negative effect, which means add or subtract to that 27 up there. Because it's a minimization problem, a negative effect would be increasing the cost, and so you would add it. So we got 8 times 60 cents, which is $4.80. Add it. Next, the next change is going from 2 to 3, which is 1 unit. This tells you the effect it will have if it's going up, which is what kind of effect?
Negative.
Negative effect. 1 times 450 gets added or subtracted to wherever we're at so far after we added the other one. Add that also, there's your new objective function value. That's it. You guys are ready.
Yes.
That's it. We're doing the in-class and getting out of here and studying for the next 2 days. So I want everybody to ace it. I know it won't happen, but God, I'm going to pray. You don't know how much I would just, it'd be a dream come true to give everybody an ace. Dream.